incandescents use way too much electricity for the amount of light we get, so they're not efficient. The other alternatives either have pollution issues like mercury, or shorter life, or poor quality, or their light distribution can't be used in all lamps. They have very limited application. So my motivation in coming is to bring a solution that you can buy one lamp, it can go anywhere the incandescent was, and it's efficient, and it lasts for years and years without ever having to think about it. And so really solving that problem, bringing a solution, not just technically, but to a store shelf, and a very economic solution, is really what drives me and motivates me today. In back of me, actually, we have bulbs that have been running for over 30,000 hours. They're some of the first test bulbs that we put together using this particular liquid that you'll see in the lamps that we have on the store shelves today. It's basically the same chemical composition as we used and started testing these bulbs over 3.5 years ago. Each one of our lamps is filled with liquid, and the LEDs get hot. They heat up the liquid expands. That causes it to become more buoyant and rises to the top of the glass or the plastic shell, where it starts to cool and become more dense. At that point, the liquid moves along the shell, getting cooler, and then gets pulled back up towards the LEDs near the hot region of the liquid again. This sets up a convection cell, which cools the LEDs and keeps them cool and more efficient. The unique part about the lamps this switch has is that because they're running cooling, they can run more efficient, they actually put out more light per LED. This means that we can actually get higher lumen output or higher watt equivalence performance out of our lamps. Alternatively, if we set a lumen output limit, we can actually use less LEDs to achieve the same light output as competitive lamps. Therefore, we have lower cost lamps that we can make for the marketplace. We started using a gel to cool the LEDs to get the efficiency of the light output using LEDs. But we found that that didn't work as efficiently, and so we moved to a liquid solution to cool the LEDs. And at that point, it cooled them very well, but the lamp geometry wasn't made to cool efficiently as the bulb was in the base up or base down position. And so we had to bring the LEDs to the center of the bulb so that the convection cells could actually cool efficiently, whether the bulb was in a ceiling, or whether it was in a lamp, or whether it was in a sideways sconce. And so that allowed the convection cell to efficiently cool the LEDs, no matter what orientation or position the bulb was actually in. And in fact, the cooling works so well that the LEDs operate within about 1 degree centigrade in any of these orientations, which means that the bulb has the same long life and reliability no matter where it's used.